Hello, welcome to my channel. In this video, we are going to be taking a look at another problem under projectile motion. And the problem we are going to be solving has a diagram of this form. So the question that can come up from this diagram is giving us what must be the velocity of the ball for it to land in the bowl. So we want to launch this ball into this bowl successfully. So as an expert, we must be able to determine the velocity needed to launch it into this bowl. So first of all, we need to have some label in this diagram. And the first label is to know the radius of this bowl. And it is given as R from this point to this point. That's the bowl is a semicircle, right? Or hemisphere, sorry to say. Then we also have the height from here to here is given as R. Then we also know the distance from this point to this point, just this side here, as 5R. So to solve this problem, we start with this general equation of projectile, which is given as y equal to x tan theta minus 2gx all over this expression, where our theta is 45 degrees, our v is what we are interested in, then our y here is this height from this point from the ground to this point, which is r, right? Then our x, for now, we can just keep it as x. When we get to where we need to find the value of x, we'll explain how to get the value. So now that we know that our y here is r, remember our r is above the origin. And if our r is above the origin, it takes positive value. When r is below the origin, it takes negative value. So now that it is above the origin, it takes positive value. And our theta is 45. Then we fix in every other part. So we have r equal to x tan 45 minus gx squared all over 2v squared cos squared 45. Tan 45 is 1. Cos 45 is 1 over root 2. So if we square it, that gives us 1 over 2. So that 1 over 2 cancels this. So we have this value, r equal to x minus gx squared all over v. Mind you, we are interested in v squared. So we can send this one back to this place and send r, capital letter R, to this part. So we have this. So we can take this one up, take this one down, and do the same thing here. And we have something of this form. So if we send this one back to this part, we have v squared equal to this. So if we make our v the Sevier formula, we have this expression. So our v is given by this expression. This is the general v. So when we know the value of x, that will now give us the velocity with which you can launch from this point to that point of x. Now, what we want to consider is the point from this point to this point. That is this one, the velocity with which you launch from here to this point, which is 5r, right? So to do that, wherever we see our x, we replace with 5r, and that gives us g times 5r all squared, because it is x squared, gives 25r squared all over 5r minus r. You know, here was x before, so 5r minus r. And that gives us g, 25r squared, 4r. So r takes care of r, and we have our gr, 25 over 4. You can bring it out with the square roots. So that gives us this value. So if we go back to the diagram, then the next thing we also need to do is to find the velocity with which we can launch to this point also. And to get this point, which is the x, we remember that this side is 5r. From here to here is going to give us r. From here to here is also going to give us r. So the velocity needed to launch this ball to this point here is going to be 5r plus r plus r, that's 7r. So if we fix it in this particular, the previous formula for v, we'll have v equal to g times 7r all squared, which will give us 49r squared, all over x minus r, where our x is 7r minus r. And from there, when we simplify, we get our 49gr. You remember r square will cancel one of these r when it becomes 6. So if you take this 49 out, square root of 49 over 6, that will give us v equal to 2.86 square root of gr. Now, this velocity at this point, right, is the velocity needed to launch this ball to hit this particular point. Why this velocity is the velocity of this ball needed to hit this particular point. So what we must do is to avoid these two velocities in order to get into this point. So the velocity needed to launch into this particular ball must be greater than this and must be less than this, which is giving us 25 must be less than this velocity and must be less than this particular one. So anything within these two velocities will get into this ball. But anything outside, if it is less than this, it will fall within this side. If it is greater than this, it falls within this side. I hope this video helps. Please like, share, and follow. Thank you.